Hello students, today we will learn about JK Latch and I will particularly talk about what is the race around condition of JK Latch by the help of animation, because I have gone through many lectures and I have seen that this is the lacking of the demonstration, means animation can make you understand better. So coming to the topic, you know what is SR latch. This is a SR latch composed of two NAND gates. Okay, and for NAND gate, we know that in case any one input to a NAND gate is 0, then output is 1. Okay, so the feedback of this upper NAND gate is given to the lower NAND gate. You can see, and the feedback of this lower NAND gate is given to the upper NAND gate. Okay, and S and R are the inputs which we can render to the gates. Okay, and this Q and Q naught are the outputs. Okay, so over here you can see that the inputs are 1 and 1. In case both the inputs are 1 for NAND gate, then the output will be 0. This 0 will be fed to this lower NAND gate. So one of the input becomes 0, then output will be 1. So the output of this lower NAND gate is fed to the upper NAND gate. So you can see, so this is the SR latch which is right now in equilibrium. Okay, now what is a JK latch? In JK latch, what happens? The same SR latch over here, S and R are the inputs. So you can see here, these two NAND gates B and D are making an SR latch whose input are connected to two more NAND gates. You can see A and C are the NAND gates. So the output of these A and C are connected to the S and R of this SR latch, B and D, composed of B and D. Okay. Now, one more thing you can see that the output of this NAND gate B is feedback to the NAND gate D as well as feedback to the NAND gate C also. You can see. Similarly, the output of this NAND gate D is feedback to the NAND gate B as well as feedback to the NAND gate A also. Okay, and these A and C are composed of two inputs J and K. This is the reason this is called as JK latch, and there is one more common input to this A and C, that is called as enable. So right now it is 0. So the purpose of enable is that in case enable is 1, only then these two NAND gates A and C are in working mode, otherwise they will not work. Because you know this thing that for an AND gate, in case any one input is 0, then output is 1. So in case enable is 0, then output of both A and C will remain 1 and no change will occur. Okay, now let's start. I will talk about what is racing condition. Racing condition occurs in case enable, J and K, all these three inputs are 1, then the racing condition occurs. Now how? Let's learn by the help of animation. Okay, now over here we see that enable and J and K both are 1. So for this NAND gate A, all the inputs are 1. So in case all the inputs are 1, then output must be 0. So you can see it has converted into 0. Now this 0 is when fed to this NAND gate B, the output will be 1, because any one input is 0, then output of NAND gate is 1. So the 1 is the output. Now this 1 will be the feedback to the NAND gate D as well as feedback to the NAND gate C also. So you can see the 1 is the input to NAND gate D as well as C also. Okay. Now what we see that for this NAND gate D, the inputs are 1 and 1. So both are 1, then output of this D will be 0. Now this 0 will go to the feedback of B as well as it will also go to the feedback of A, like this. So it has gone. Now for this NAND gate A, one of the input becomes 0, so its output must be 1, so it is 1, like this. Okay, now we can see that for this NAND gate C, all the inputs are 1, so the output must be 0, so it has been converted into 0. Now when 0 is fed to this NAND gate D, again the output will be 1, so it is 1. So this one will be fed to B as well as A also, so it has gone to B as well as A also. Now for this NAND gate B, both the inputs are 1, so output must be 0, so it is 0. Now this 0 is fed to NAND gate D as well as C also, so like this, so it is fed to D as well as C also. Okay, so when one of the input of this C becomes 0, then output must be 1, so here it is 1. Okay, now what we see that A is again fed with three inputs, all the three inputs to be 1. So this is the initial condition from where we did start. We have arrived to the same condition. So what will happen? Again, the entire activity will happen in a cyclic fashion. So in case all the three inputs are 1, J and K and enable are 1, then the outputs will be reversed automatically in a cyclic fashion like this. You can see J, K and enable are 1. So output is inverting continuously in a cyclic fashion. So this is what the racing condition is. Means in case all the three inputs JK and enable are converted into one, then the output of this JK latch will keep on toggling like this. Okay. So hope with this small lecture you would have understood that what is the racing condition of a JK latch. Thank you.